All right, welcome Web39 Foundations to Friday. Now, normally at Lambda School, we do not have class on Friday. Usually it's an assessment day and a self-reflection day. So what I mean by that is usually you're doing a project without instruction, and that project has a rubric, and you're trying to accomplish the goals of that rubric in a set amount of time. And then you self-reflect on the week using the forms inside of Canvas. Because Foundations is so fast and furious, and we're trying to cover so much content, we have opted to use this day instead as a teaching day, and Monday and Tuesday as teaching days. So we won't have a summation or a total project, a summative project. We're not going to be doing any of that in Foundations because we're just trying to expose. So everything about Foundations is exposure. And I think some of you have done a good job of keeping that context, and you're going, okay, I'm being exposed to content. I think some of you have over indexed on trying to be perfect, trying to get everything right, trying to go further on every project. And hopefully, like this moment right now, I can shake you a little bit, grab your shoulders, and be like, that's not the intention. The intention of Foundations is exposure. It's trying to get you to see things that are further down the line, and going, oh, that's pretty cool. It doesn't mean you have to see it and go, I need to be an expert at it right this second. I've seen a lot of you struggling mightily with not just getting it instantly and then going, well, I must be dumb or I must not be able to do this. And you've got to address that inner voice to understand that, like, that's not the goal of Foundations. The goal is to say, hey, here's some stuff in JavaScript. It's good for you to know it now. It's not good for you to expect yourself to master it. It takes years to master this stuff, but you can be exposed to it and learn about it. So yeah, Joshua Albert says, I learned that APIs are super cool. That's exactly it. You're just supposed to go, APIs are cool from yesterday, for example. It doesn't mean you have to go and learn how to use an API. Okay, so that's my little learning. And yesterday there were so many good comments from this group of students, like so good. A lot of you had really good critical feedback around how deep or not deep we should be going. And I think the big message that I gathered from everyone was it doesn't matter how far we go in terms of depth as long as we understand like why it's useful. And one of our students here pointed out to me like, hey, if I understood the value of something, then it's going to make it a lot easier to learn. I just love that. So for me, I want to showcase more of the value today of what we're doing first, and then we're going to go back and we'll reverse engineer to how it works. So yesterday we started with how it works, and then we got to the value by end of class. So the value, of course, was lambda times and showing you how to like update the temperature. Like that was cool. I want to start there today, and then we're going to go back. So we're going to reverse engineer the experience from yesterday to showcase why it's important. So I just need you all to understand that like JavaScript, without JavaScript, our pages would be static. There would be no interactivity. So for example, this Slido application in front of you would not work without JavaScript because this is static HTML. Static means that it has no brains. It's just sitting on the page. But you'll notice that if we try sending a question or watch a tutorial, these buttons right here are triggered by JavaScript. And so if we don't have JavaScript, our pages cease to function the way that we would want them to function. And honestly, the internet would be awful without a scripting language like JavaScript because our web pages would do nothing. They would be purely informational. And so the fact that we can interact, we can send a question, we can set up polls, like the fact that I can even do this right here without refreshing the page. Maybe you're not noticing that right now, but all that's changing is the URL. That's because we're in a JavaScript application, but you probably didn't realize that, right? Versus if you go to another web page, like Lambda School, for example, you'll notice that if I go to another page, it'll refresh the page. So watch this. If I open this up and I go to admissions, watch the page as soon as I click this. Oops, got to click. Notice the whole page had to reload. A new set of JavaScript. CSS had to repaint the screen. That takes a lot of effort for the browser to do, and it's not a really congruent experience. Now, that's okay though, because this web page is meant to be informational. But then you come down here and we want to interact with it. So full-time, part-time additional options for web only. This little doohickey right here, this is game changing for people to understand, like, oh, I can look at my mountain time. Well, I'm in Central, I'm Eastern. That's so cool. And by the way, this is all done in JavaScript. 100% of this is done with JavaScript. And so if we don't have JavaScript built into our experiences, this would not be possible. Instead, it would be this huge, huge page with no interactivity. These videos, that's right, JavaScript. They're allowing us to click them in and go into them.
So everything that I notice about what makes me great at my job is how, number one, independent I am. I don't really
look at JavaScript not being able to shut that down.
Whenever I'm stuck, I don't really need people to
gotta zoom out.
to do next or people to help me
find. I'm zoomed in too much on my web page here. Okay, so Joram, by the way, he's one of my students. He was an amazing student at the beginning. Oh, it's crazy to see these people, and I'm going, these people were you, and now they're videos, they're testimonials. Why? Because they took time to learn JavaScript. So it's pretty crazy. Hopefully you're seeing the value of JavaScript as it pertains to dynamic web pages, because if we didn't have it, this menu system doesn't work. If we didn't have it, we can't actually click into any of our apps like this. So just keep that in mind as we're working on the things that we're doing today. So now what I want to do is I gave everybody the Lambda project. So you should all have it from the last 2 days. So I'm going to go ahead and go into Web39 folder. So we're going to start here. And I just add the Lambda times. Any changes that I make, I'll just say module 5 just to be consistent for me, but really we're not going to change anything. But my OCD states that I must have a new folder for a new day. So there's our module 5. Okay. So here's Lambda times again from yesterday. And let's open this up. Now, I say let's, but maybe I just want you to pay attention and not necessarily get caught in trying to keep up with me at this point. So don't try to keep up with me. This is like show and tell portion. And then we'll get to a portion where I want you to code along with me. So as we look at the code, first things first, this is review, but I want to review. You got to hit this go live button because of the server, and it's going to open up a browser, right? And notice the URL is 127, right? So we talked about this being our local machine and how our local machine is code that we write. Okay. So for JavaScript to even work on this page, we need to have this link tag. Oops, sorry, not the link tag. Where's my script tag? Oh, yesterday I had it at the bottom of the page. I remember now. So yesterday I explained to you how modern JavaScripters will often put the script tag back in the head with an async tag. So that was discussed yesterday. We just throw in the async here so it doesn't block HTML. Okay. So notice how we have the 25 degrees, we have Tuesday, we have 2020. These were all pieces that we were putting in using JavaScript yesterday. So I'm going to go ahead and just comment this out and you'll see, hit save, and all my JavaScript stuff dies. So you see how JavaScript is so important to our web page here for our dynamicy. So we don't have 2020 anymore. Our articles are going to be weird and our temperature is gone. So we have to bring this thing back in and hit save. And then you'll see our JavaScript comes back in and here we are. So one of the things that we're going to be talking about today is control structure. So yesterday I showed you how we could use the temperature, how we could use variables to bring a temperature in. So let's start with where we want to get, and then we'll go backwards. So here we go. right here. So today we're going to be talking about for loops, and we're going to be talking about control flow. Control flow is all about finding something that's true or false. But in order to get there, why does this even matter? So if we come over here, I want you to see we've got a for loop, and we're going through a list of articles. And then what we're doing is we're making all the articles titles, and we're saying based on the search input. So we've got a search bar up here. I'm going to type in, the flavors of object-oriented in JavaScript. Oh. So every time I type something, you can see something changes. That's not magic. That's JavaScript. So we're using JavaScript to create this really good interaction for us to be able to search every article in this, made up Lambda Times website, right? So this is a feature you're going to see in a lot of things that you do in your life as a developer, is you're going to have to go through a lot of information and then bring that information up in a UI for a user. So this, my friends, is the beginning of both the for loop and the conditional logic that we're going to be talking about today. So by the end of today, you will understand better how we can loop through a lot of content to display it just like this. So this code right here is doing everything that you're seeing when we type in a letter. So I want to show you really quick, reverse engineer it with you, and then we'll go back to CodePen and start looking at like the fundamental pieces of this. So up here, you can see we've got a search input. And so this search input is going to be our element. So I'm going to right click on this, inspect element. Remember, you can do this. Anybody can do this. Right click on anything and you can inspect anything to learn more about it. So I've got an input type over here, and it says type text, placeholder, search, ID, search. So let's see if we can find an ID of search in here. And in fact, an ID is going to look like the hash symbol because it's CSS. So you can see right here that we've got const search input. So look, hey, there's a variable. We learned this yesterday. Pretty cool. Assign the value of, and then here's the stuff that you don't know yet, but that's okay. So this is a moment where I want to say, it's okay you don't know everything right here. But you should know now from yesterday that document is a virtual representation of this web page. And we can traverse that virtual representation using getElementById. So this is the document object model API. Isn't that pretty cool? You're actually using an API. So that's kind of just a fun, nerdy thing to stop here and say, you're actually interfacing with the browser with your own code. And that's how we get there. And then search is going to say, so this says getElementById. So this requires us to return an ID. So guess what? There is an ID right there. We learned about this in HTML. So input, text, assign the value of text, placeholder, search, and then ID, assign the value of search. So guess what? We can hook into that using our document object model hook. Now remember, document object model is not the goal today, but I want to show you and like demystify as much as I can. You will eventually start learning this stuff very soon in terms of how to manipulate the web page. So you can see now how HTML, because remember, this is HTML right here, CSS, so we're using this ID selector, which is in CSS, and JavaScript, which is right here, work together to solve problems like trying to create a search bar that automatically updates every time you type a letter. So cool, right? So this is the reason, this is like the problem we're trying to solve today, is this search bar. To get there, we have to have a good knowledge of HTML, CSS, and JavaScript working together to solve the problem. So I'm not going to go through every line of code here. I don't think it's worth our time to do that right now. More than I want to show you that this search bar is getting grabbed, and then we're adding an event listener, and we're listening for a key up event. And then when that key up event triggers, we start this new thing, which allows us to look for every article. Now, here's the for loop. So we're going to be talking about for loops in great depth today, but hopefully you watched the video before class and you've kind of been exposed to for loops a little bit. And so here's a for loop in the wild right before us, right? And so what it's doing is it's saying, hey, for every article that's on the web page, that's what that means, go through every article and let's make sure that we add every article to this variable articles. And we're going to make every title lowercase. That's just a design thing that maybe the designer told us to do. So we're going to say make it to lowercase. So if we come in here, you can see everything is lowercase once we get past the article name. Now, of course, we didn't set up everything. The article page doesn't exist for real. We just wanted to set up the search over here. And so what we're doing is while we're looking for the article, we're making everything lowercase so we don't have to worry about different cases wrecking the person's input. Then we're going to use an if statement here, which we're going to learn about today. And we're going to say, if whatever is inside here is true, do the following. So that's how if statements work. They check for truthiness or falsiness, and then they run a statement. So in this case, it says, if the title includes the search text, which remember, the search text is anything we're typing. So curriculum, you can see how it's checking every single thing. And then it's saying, hey, I found an article that matches that. So that's what this search text does. And then it says add result to page article. And that's what this is. This is the article. Pretty cool. So this is like what you would use it for to solve a problem with. You would use conditionals to check to see if something is true or false, so you can show it or not. You would use for loops to go through n amount of articles. Now, developers say n, they mean infinite amount, any amount. So you'll often hear developers say n amount of, and that means an infinite amount. We don't know yet. Because what if this had 10,000 articles? What if this had 10 articles? What if this had 0 articles? So this for loop is meant to find every article possible that matches our condition, which, by the way, is if the title includes a search text. So every time we type a letter, it updates that loop with new articles. Pretty slick, right? So this, my friends, is how a real world JavaScript use case would benefit you to learn this, because you would greatly benefit from understanding how to use a for loop to go through a bunch of data and how to make conditional statements based on if something was true or false, because then you can make a decision. So that the decision is obviously made by the machine, but you as a developer, as a human, can put in your logic to get there. Now, this is like, whoa, this is so much information. But if we boil it down to the fundamentals that we're about to go jump into, it's just saying, go through a bunch of stuff, check if something's true. If that's not true, check if this is true. That's it. It's pretty simple in terms of like what it's trying to do. It's trying to go through a bunch of items and check if something's true or false. That's really kind of like programming 101. Loop through a bunch of stuff, check if something's true or not, return a value. That's programming. Okay, so let me stop here. Let's see if there's any questions in the Slido. So Felix says, does it matter the line where you put the async at before or after anything specifically? I think it does matter, Felix. So let me show you. Felix was asking about this line. Oh, Felix, I guess you were saying, does it matter if you put it here? Attributes, it doesn't matter where you put attributes. As long as they're space separated, that's all that matters. So you do need to put it in that opening script tag, Felix. Like you wouldn't put it here, for example, it would break. So it does matter that it's in the opening tag here, but outside of that, it only matters that it's in it. So good question. Any other questions? Oh, the whole line per se? Okay, so the whole line's going to be, I like to put it in the head tag, but everybody's got a little, like this is a big boss decision, but I like to put all my stuff together, meaning all my CSS, my fonts, all my script tags. They make a lot of sense. Anything that you're bringing in externally, I like to chunk together personally when I'm working on a project, so I don't have to go try to search for it. You know, It sucks for the next developer to try to look for all your code. Okay. All right. Let me see if there's any other questions. Any questions about the search tool that I walked through here to show you like why this stuff's useful? Of course, you can ask questions about anything you don't know. Like if you're like, I want to know more about the DOM or something, go for it. But any questions inside of here for our Q&A right now? Okay, not seeing any pop in. So what I'm going to do is we're going to jump over to CodePen now, and we're going to start walking backwards from what we've been doing and writing code and introducing a lot of the fundamental concepts of why this stuff works. So of course, notice over here that we don't have this search bar over here. We're not going to be doing the search bar per se. We're just going to be walking through the logic of like how to get this thing working with just conditional statements. So it's not going to be, we're not going to copy and paste the HTML over. It's already there. We've already walked through that piece at the bottom of this page. So this is how it works. But I want to focus on like, how does a for loop work? How does an if statement work? So that's what we're going to talk about next. Okay, so hopefully that was good in helping us set the stage and frame why this stuff's so important to us to learn. So now we're going to go into our JavaScript portion, and we're going to start trying to figure out how does this thing work from the beginning. So the first thing we need to understand to get this thing to work is truthy or falsy. Now, interesting that I'm saying truthy or falsy. It even sounds kind of childish, doesn't it? It's like truthy, falsy. I don't know. First time I read that, I was like, what? Because I'm used to true and false, black and white, Booleans, right? It's just like, it's one or the other. You know what it is. But in JavaScript, it's pretty gray. It's truthy or falsy. And we talked about this yesterday, or at least it was inside of your module project, inside of your modules. I think it's worth showing you where it is, just as a reminder. So it's in module 4, and we talked about the foundations of the math global object, and basically truthiness was inside of here. So I want to talk about this because this really impacts what we're doing today. So items that are interpreted as true by JavaScript, well, literally the Boolean true makes sense. A number. So if a number is a valid number, JavaScript says, yeah, that's generally true. And that's a weird concept to us as humans because why is number 1 true? And that's because the interpreter in JavaScript says, is it truthy or falsy? And JavaScript says, this is true, versus a 0 is false, according to JavaScript's interpreter. And so what JavaScript is looking for is things that are generally true and things that are generally false. The list of things that are false is very short compared to the list of things that are true. So, I mean, any string, number, Boolean, this is all true in terms of like their values. Functions, arrays, and objects, which we'll learn more about in the coming in Monday and Tuesday. These are also considered to be true. But then if we come down here, you can see false is literally false. 0 is false. Undefined is false. Null is false. And then notice that there's an interesting thing here with a string with no value in it. So let's go try these things out. And in fact, let me just pull this up one-to-one so we can kind of see them in action. So how do we know something is true or false? Well, let's go look at the console log and see. So I'm going to go ahead and just jump in the real console. I'm going to clear it because there's all sorts of stuff. And let's just type in, I'm going to type in, everybody do this with me. So let's get fingers on keyboard. I've been like showing you stuff. Let's kind of stop. Everybody jump in your browser. It doesn't have to be CodePen. It could be any, just open up a browser, right click, inspect, and open up your console so you've got your browser's console in front of you. So do that really quick. Let's get everybody in the console because I want us to see the console in action and see like, what does this look like? Okay, so everybody go ahead and just type in 0. And then hit enter. And you'll notice right here, it just says, see these little arrows? I'm going to zoom in. You don't need to zoom in. I'm just going to zoom in. So this was the input. See how the arrow is facing this way? It means this is your input. And then the console returned back this 0. So now what I want everybody to do is type in if, like that. And then I'm going to say open and close parentheses, like that. So this is an interesting thing because this is syntax that was from this morning from studying. So I want everybody to type 0 inside of this if. And then I want you to open and close some curly braces like that. And then I want you to say console.log, open and close. I'll wait for you, don't worry. Say, this is true. Okay. Don't hit enter yet. Let's just look at this for a second. So if open and close parentheses, and there's a 0 inside of it, then we have a block of code. So remember, these curly braces are a block of code. We're then using console log to say, hey, if this statement reads out to be true, then I want you to run this string, this is true. Okay, so now I'm going to hit enter. Notice it didn't run. That is because 0 is considered to be false according to JavaScript. So now I want everybody to hit the up arrow. The up arrow allows you to go back to something you wrote without having to retype everything. And I want you to go back to this. I want you to type in 1. And now let's go over here and hit enter again. And look at that. It says, this is true. So you can see the difference right here by using an if statement, what is truthy and what is falsy. Why does this matter? Why does this matter to us? So if we go back into our code over here, if we couldn't tell if there was search text in the input, if we couldn't tell if that was true or false, our program would cease to run. That's how important truthiness and falsiness is as a developer. So for example, if I couldn't tell that there was something in here, if something in here was true or false, I wouldn't be able to filter. So true and false is so important to us as a developer, so we can find out if somebody actually has a letter in here, true or false. Is there a letter in here, true or false? And then based on that decision, we make a new code, right? We make a new move. And our new move in this case is add to results page, which is going to give us the article that all this stuff. This is called the result page, this white box. So we're adding articles to it. So because this is true, so right now that's false. True, false, true, false. That's how important understanding control flow is, and if something's true or false. Okay, let's go back to our browser that we were working in. So we're going to try another one. So just hit the up arrow. Let's go back to number 1. And let's try out another thing from our list. Let's try a string with a space in it. So string, space, string. Just like that, little Kirby face. So I'm going to hit enter. Let's see if this is true or false. This is true. So we can see that a string with a space in it actually computes to be truthy. Now I'm going to hit the up arrow again. I'm going to go back to that string and get rid of the space. See if that's false. Come over here, hit enter. False, because it didn't run. Now, hopefully, some of you are going, what the crap is undefined? I keep seeing undefined. Why does undefined keep showing up? The answer to that question lies within the return statement, which we haven't talked about yet because it's not time yet. But usually functions will return a value or a block of code will return a value back to the browser. And when nothing is returned, the browser says, just so you know, it's undefined. So when we start getting into functions next week, we'll address this undefined. But for now, don't stress about it because we're not worried about returning anything. We're just trying to figure out if this is true or not. Okay, so now that we've delved into truthiness and falsiness, we can start getting into, of course, the strange behavior of JavaScript's type coercion from yesterday. So go ahead and hit the up arrow again. And what we're going to do is we're going to go back over to our if statement block. And we're going to say, okay, JavaScript, you weird little beast, 2 plus 2. Now, don't hit enter yet. Let's just think about this out loud. Remember, we always want to try to think about these things out loud to ourselves. Okay, so 2 is true. We know it's true, right? It's a number, so it's true. We also know that a string is true, right? We just demonstrated that a string is true. So 2 plus 2 is going to equate to a new string because of weird JavaScript type coercion. So this is going to equate to 22 as a string. So we can make the assumption that because it's going to be a string, that this is going to be true. Okay, so let's hit enter. And it is true. Okay. So this is the kind of behavior that you need to be aware of as a developer when you're trying to figure out, like, if you're going through articles, for example, you got to make sure that you're thinking about this interesting behavior to say, I got to be careful, is this true or false? So quite literally, the only thing control structure and control flows and if statements do, the only thing they're concerned with is truthiness or falsiness. That's all they look for inside of those parentheses. It's actually kind of like a relief to know it's that simple. So this chunk right here, in all of programming, in all of JavaScript programming, all if statements are ever trying to do is check for truth or false. That's all they care about. They don't care about the actual result more than they care about true or false. Isn't that crazy? So they don't care that it's 22. They care, is it true or false? And so now that you know that, you're armed with the knowledge of being able to traverse the control flow way better because you're just looking for truth and false. You're not really worried about like the number. The numbers matter more in the guts inside of here. So this is where numbers matter because like we want to like maybe add 10 or -5 or something like that. But inside of here, inside of this condition, we only care about truth or false. Hopefully that's crystal clear because if statements you need to understand that knowledge for the rest of JavaScript to start making sense. Because if we go back into our code from up here, now we can look at this with new light. This is saying if the title includes search text, it's saying true or false. Does the title include search text? That's what it's really asking. That's all this if statement's really doing. But of course, that would be really cumbersome to write. And so we have syntax that helps us understand these things. And we just know, okay, is it true or false based on the result of does the title dot includes search text, yes or no? If yes, do this. If no, do nothing. So that's the interesting thing. Notice here, there's no conditional statement after the if statement. So I would, if I were you, I'd probably be going, wait a second. Okay, if that's true, cool, I get it. Do this. Okay. But what happens if it's false? Well, if you don't have a catch statement or a statement that's listening, nothing will happen. It'll just die, meaning no bad or good thing will happen. It just ceases to function. So what that means is that like if I don't have a value, and here you can see it's not adding more articles. It's just doing one, right? No articles match your search. So, and you can see right here, if the search results children length, meaning the amount of articles that match this condition are 0, then return this value. No articles match your search. So that's what's happening here is there are literally no more articles that match SDFSS, SDFSS. There's nothing that's truthy about that for our statement. So if we come back over here, let's go into CodePen. So now I'm going to have you to zoom out a second and just come back to just watching me code for a second. And of course, you have this link inside of your Slack. So I'm going to say if open and close parentheses, curly braces. So this is what we were writing inside the console, just with better white spacing. And then if I put in a 1, then we could say, console.log. And remember, we only use console log for debugging. This is true. So we've got this far, right? So I'm going to hit save and run, and we should see this is true pop up in the console. There it is. Because why? Because 1 is true. It's truthy, right? And then if I put a 0 in here, we've learned that 0 is falsy. So I'm going to save and run. You can see nothing happens. But this is kind of annoying because as a human, I want to know if it's false. I want to know what's going on. So guess what? We can use a new statement called else, like that. And we can open this up with a new block of code. See that syntax? It's almost too easy. It's almost too easy to write that because you're just like, isn't there a semicolon or something there? Nope. After the closing curly, if we put an else right there, this will be our default statement if it's not true. So I'm going to say console.log. This is false. Now remember, I'm not expecting you to keep up with me. I'm expecting you just to watch for a second. So now that we've got 0, I'm going to hit run. And you can see it says this is false. Hey, that's pretty cool because we basically caught that this is doing something that's falsy. And of course, if I put in the 1 again, clear my console, save and run again, it should say this is true now, showing you that it's not getting to this statement at all. Pretty freaking cool because now we can control whether something pops up or not. It's the same concept going on right here between these two. Even though this is a silly representation, it's just true or false. Okay, let me stop here and answer any questions we may have. Rory says, does the interpreter run off binary rules like 0s equal close, 1s fall, open, true? So the interpreter runs off of, it's a little bit more advanced. It's depends on the engine of the browser, meaning it's more advanced than I can tell you exactly how. But yes, Rory, it ultimately comes down to machine code and binary. So 1s and 0s being interpreted by the browser. But again, that's not something you need to worry about unless you're planning on building browser engine code. So for us, we just need to know that the browser is interpreting and then just in time compiling for us to see the results. As a developer, that we're at a very high level, whereas the code that's actually operating is on a low level. It's on the machine, it's on the metal, it's on our computers running. So great question, Rory, but the answer really is it doesn't really concern us at this level because we're using high level programming to abstract off of the metal from our computer. Pretty crazy. Okay, let's take a 5-minute breather. Okay, Marcus says, so don't need a semicolon at the end? Nope, you don't. So that's the cool thing is remember semicolons are optional for statements. You don't really need them. But for consistency's sake, I probably should put that. I don't need a semicolon here either because this is an end of block of code. So the interpreter understands that. So I don't have to do like that. So we're good to go there. Good question, Marcus. Okay, let's take a 5-minute breather. When we come back, we'll keep going down the path, control structures, and start getting into for loops. Take a break. All right. Hopefully this approach has been more scaffolded. I feel like it's been. I feel like it's been good to go from the end result back to the beginning. I think it's been way better actually. But hopefully now in review, we're looking at this and we're going, okay, how this if statement, for example, if we started with the if statement, we didn't understand like why it was useful. Now we're starting with the usefulness and going backwards. It's pretty cool to see the difference. Inside this if statement, we've got truthiness or falsiness, right? We're then executing code based on if it's true. And then we've got a little else statement here to see if it's false. Now, of course, as with almost everything in JavaScript, we can expand on this idea. So guess what? We can expand to say else if. That's right. We can throw another if inside there and check against more truthiness or falsiness. So the interesting thing here is we could go, well, if this thing's not true and this thing over here is not true, then we can say it's false. So if we come over here and we just throw our else at the bottom again, or just this is kind of our catch-all. This is the way I think about the last else. This is our catch-all statement. Now, I want you to remember that if we go back to Visual Studio Code and we look at our article, there's no else if here, right? Because we don't care if anything else happens. We just want to know, is there going to be a result added to the page? If not, meh, we don't care. There's no error that needs to run. There's no user experience that needs to change. We simply don't add the article to the page. So that's why we don't have to put an else here, because it really does nothing for us. Now we could console log it just for fun. So like no article was added. So I'm going to go ahead and just pop this in and hit save. And then I'm going to go over to our log. I'm going to go down to our, this thing's zoomed in. Hold on. There we go. And okay. So as I type in a letter, let's see what happens. A. So see what happens. It says there were no articles added for 3 of the articles that didn't match the A. Make sense? So we don't care about the articles that weren't added, and that's why there's no need for an else statement. Let's type in B. This had even less articles to add. So this really does nothing for us in terms of the user experience. The user doesn't benefit from knowing how many articles didn't match, for example. So that's why we can just have it die and not have to deal with the result. Pretty cool. So that's why we don't have else's on everything. So if we come back to our code over here, you can see that like this is definitely contrived to just show us the difference. But the real example over here shows us like we don't need to, I don't care about these nine articles. It doesn't matter. So if I come over here and let's just put in another thing that is something that is true. So we can literally just type in a string. This is true. Actually, that'll be confusing because it's the value. I'll just say string value. Console.log. I can say this is also true. Now, we haven't talked about like when something's true, does it stop the statement? We haven't talked about that yet. So in this case, this if one we know is truthy. We also know that this else if string value is also truthy. So by the way, I always want to have little spaces here just for some code cleanliness. And of course, Prettier would do that for us inside of our VS Code extension. So inside of here, if one is true, so this will run. Now, the question is, do you think that if something's true up here, it'll run the next thing? Let's try it out. So I'm going to hit save. And right now, I don't know. Let's pretend I don't know the answer. So I'm not really sure. If this is true and this is true, let's try it. So I'm gonna hit run. And let's see what happens. So this is true. So that means that this top line ran, and then the statement basically stopped. So what happens is if you're using an if else structure like this, it's going to continue to go. It's going to find the if statement that stops, and then it's just going to end because we don't have anything else. Now, what if we didn't have this else? So what if I deleted that else and just had if? Let's try this out, because basically that's what it would look like. So I'm going to hit clear, save, and run. And you can see if I don't have an else after this curly brace, it treats this like a brand new statement. So else is really great in protecting us from having a bunch of true answers. So that's why if you want to make sure if something is truly true or not, and then you stop doing something with it, else if does that for us. So if we go back to our example over here, we're checking multiple if statements if we need to run any code. So obviously the same thing exists here, except now, we can control this structure if we want to. So that, my friends, is considered control flow. We're controlling the flow of code based on truthiness or falsiness. It's that simple, like in terms of like a sentence to describe what we're doing. But of course, the execution, thinking around it is complex because you have to go, what has to be true? Okay, so yesterday we didn't really get to delve into comparison operators too much. It was just written down and expected that you would read it. But I do want you to look at this to understand that comparison operators matter big time when trying to figure out if something's truthy or falsy. So for example, a comparison operator would be like this, a double equal sign. So we would check to say, is 1 equal to 1? And of course, we can come up here and say clear, save, and run and see what happens. And say this is true. So this first statement is true. 1 is equal to 1. Now, of course, if I put in a quote, we're now entering into types. So the type on the left is a number. The type on the right is a string. So now we've got to find out, is a string equivalent to a number? So we're going to hit run. And guess what? Inside of JavaScript with a double equals, you're going to get that, which is really confusing as a new developer. And in general, it's just confusing. It's like, what? They're not equal. But that's because in JavaScript with a doubles equal operator, you get type coercion is disregarded. We don't have to worry about it. It doesn't even include it. But if you enter a third equal sign, it then keeps type coercion in the equation and will actually check against the type as well. So we'll say run. And in this case, it skips over this first line and jumps into the next line, meaning this is false. So that's really interesting to note that triple equals allows us as developers to know if something is not only the same, but of the same type or not. So types really just will never go away in your life in JavaScript. You've always got to be aware of numbers, strings, and Booleans, and figuring out, like, are they equal to each other? And so this triple equals is great for protecting us from ourselves, if we accidentally throw in a variable. So if I were to show you an example of like how that could look, you could say like, let some number assign the value of 3, right? And then we say, so let some string assign the value of test. So if we were to come in here and check against these variables in this if statement, some number and some string, you can see that it's a number and a string. And so our triples equals should, I'm going to go ahead and get rid of this extra else if so we don't have the extra confusing statement. So we'll just say else. This is false. Okay. So I'm going to hit save and run. And we should get this is false. There it is. That's great. Now, if we use double equals, we should get this is true. Actually, I don't know. We'll see if it gets true. It'll be truthy, right? Because it's going to be a string. So even though it says, oh, here we go. It's comparing the number 3 versus the string test. So thank goodness there is some sanity in JavaScript. So it's still at least checking the TEST versus the number 3. Whew, at least JavaScript does that for us. So this is actually a really good thing for us to know that double equals still works in some case, and then it's like going to find 3 versus 3. But my goodness, the triple equals is how we should operate. So we can just avoid all of this craziness. Okay. Something else that's really interesting is using the ampersand. So it's and. So what you can do is you can actually chunk things together just like you can do in math. So in math, you could do something like this, 2 plus 2. And then you could like multiply it by 4, right? Order of operations. Well, we can do the same kind of thing inside of an if statement. We can come in here and say, if this is true, and then we can use a new thing called and. It's just ampersands twice like that. And this other thing is true, then say it's true. So it's kind of interesting. And in fact, we can use the ampersand statement just to separate them as well. So we can just do that. If some string and some, so if we do 3, so that should be true, or actually that'll be false because of our triple equals. So let's do this. If some number is equal to 3, so we know that's going to be true. First off, let's just run this really quick, save and run. And we should say this is true. There it is. And then we're going to say, and oops, some string, capitalization does matter, is equivalent to 3. So these both have to be true for us to get to this statement. So let's see if this works. Save and run. This is true because the number 3 is equivalent to the variable pointer that we created. Some string is also 3. Now, what if we change this to be 4? So only 50% of the statement is true. We'll say run. This is false. So this will often happen inside of code when we're trying to make a decision between 2 things to make sure that it's actually the right spot. Now, I don't know if this one has any clear examples on that. Yeah, it unfortunately doesn't. We'll have to work on that in the future. But using different operators is used all the time inside of code. Our examples don't have any, so I'll have to think on that and get some better examples in there. But this does happen inside of JavaScript quite a bit where you're going to be using an ampersand. Now, you can actually have only one statement be true if you use the or operator, and that's just double pipes, which is weird. It's shift, and then it's right above your enter on your keyboard. So these are called pipes. And if you use these, only one of these things needs to be true for it to run truthy. So I'm going to say run, and you can see that this is true and this is false. And because we have these double pipes, it says, okay, only one of them need to be true. And this is called the or. So this is or, and then this is ampersand and. Okay. Let's stop there in terms of control structures. You can have as many if-else statements as you want. Usually you're not going to get past maybe 3 or 4, and like more and most programming, you're not going to need to check 3 or 4 different things, but sometimes you can get into like 6 or 8 if there's like an extreme decision tree that you've got to accomplish. And in that case, you can use if-else statements just fine. There's also another statement out there called a switch statement. We won't go into it, but I just want you to know that it's out there. So we'll call it JS switch statement. And this is actually kind of interesting. It's worth looking at for a second to say it's a built-in if-else with more rules. So basically you can say, if the case is X, do this. If the case is Y, do this. but it's the same thing. It's truthiness or falsiness based on whatever's passed into it. So that's cool. It's something you should be aware of, but let's focus on basic control structures right now, because most people in programming are using just if else statements. I've actually seen more rare and rare. It's more rare to see a switch statement lately, at least in the programming I've been seeing. Okay. So this, my friends, is control flow, and it helps us. The biggest things in review are truthiness, falsiness, understanding how to get something to be true or false, and then of course doing something with your code when you know it's true or false. It's going to work really well in tandem with the next concept we're going to cover, which is for loops. Okay, let me stop here and see if there's any questions. Just refresh the page just in case I missed anything. Marcus says, should we use const instead of let in this situation in CodePen? Nope. Const is, well, remember, Marcus, for me, I like to use let until I can't. But I think the same thing applies to you. I think teaching people to use const until you can't can sometimes be a little bit too silly because you're missing the point of constant should be a constant value you never change ever. And in programming, there's very few values that are actually constants. You know, it's like a tax rate that never changes or something like that. And so I get a little nervous teaching new people only use const ever, because the whole point of variables is that you can change and manipulate data. And so the let is perfect use case for most programming. So Marcus, I love that you're calling it out, but I just want you to be aware that, like, think about const as like a forever number. Isaac says, what about the ternary operator? Don't worry about the ternary operator right now. That is beyond where we need to be right now. Ternary operators are cool. That's all I'm going to say. Don't worry about those right now. Okay. Let's see. Let me do a little poll. Let's see how we're doing. It seems like we're a little quiet today in the questions. So I'm going to come over here, run a poll, create a poll. I'm going to say, how are we feeling about control flow? And that means falsiness, truthiness, if statements, else statements. Doing great. Keep going at this speed. Doing okay. Slow down a little. Not good. I'll be reaching out to you after class, which I think you should, by the way. Okay, hit save. And then I'm going to run this one. Okay, go ahead and jump into the same Slido and vote so I can understand where we are right now. Okay, we've got 13, 14, 15. Okay, we're starting to get almost 50%. Okay, so we're seeing some confusion here. This is great for me to see. So now I'm going to ask, we're going to do a new poll. So what I want to do is go back over here. So I'm going to deactivate this poll, create a new poll. Say, what should I review? So I'm going to come over here. I'm going to say truthy and falsy concepts. If statements. Or let's say, what other concepts have we covered? The operators, the comparison operators. So it's like, you know, the triple equals or the double ampersands. Okay, let me run this one. So I'll quickly run a review on whatever we think is most impactful. Okay. Interesting. Okay, so if statements and comparison operators. You know what we should probably do is just get some reps in right now. So what I want us to do is everybody take this code pen. So here's the link. I'm going to jump in here. Just take this code pen. So what I want to do for the next, let's do 5 minutes. I want everybody to go write their own if statement. I want you to compare something. This is, of course, an example. So I'm going to just take this, comment it out. So I would love for you to try to figure out, bring up an example in your mind that you think would be useful. And it could be as simple as saying 3 or 4. But I want you to write out some if statements and I want to see them. So what I'll do is I'll give you a 5-minute timer. Take the code pen I just sent you, go into the code here and write yourself, write if statement. Statement, holy cow, here. So I want you to write your if statement here, and then I want to, after the 5 minutes, I'll open a thread, and I'll have everybody post their if statements, and we'll look at them together and talk about them. So let's do that for the next 5. So go write an if statement of your choosing. Now, sometimes that can be paralyzing with that many options. So even if you just wanted to copy and paste what I did, and you're just trying to get some finger practice, that's fine too. So 5 minutes, go write some if statements to see how they work and see if you can get your console log to run true or false. Go do that for 5. All right, time is up. Go ahead and jump inside. Looks like we've got some people posting. So go ahead and post. You can just pop your CodePen link in there if you want, or just do what Carlos and Rory have done, and they threw in their own if statements. So everybody go in there for the last 5 minutes, jump inside this thread, show me what you worked on, and we'll look at a couple and talk about the anatomy of what's going on inside of those. So I'll just go ahead and just grab Rory's up here. So inside of here, let's kind of walk through this code line by line. So let is our variable declaration. X_num is going to be the name of our variable. We're assigning the value of the number 5. Then we have another declaration called let ex string. So these are probably short for example. And then you have assigned the value of a string of 5 in single quotes, which is just fine. I prefer single quotes. So then we come over here and we look at our if statement, and then you can see we're comparing x_num, which again is going to be the number 5. We're then having the triple equals. So this is the triple equals operator. We're checking against truthiness, plus remember with the triple, we're checking against type as well. So inside of here, you can see that we have a string of 5, which is not equivalent to 5, nor is the string the same. So this should run as false. Console log, this is true, just in case it is. Else, run this statement if it's false. So I'm going to hit save and run, and we should see false. There we go. Great job. Okay, let's look at a couple more. I'll grab Carlos here. So Carlos has movie price, wallet cash. Awesome. Now notice that Carlos is going full on no semicolon, which is totally valid. But remember, it depends on where you work and what the big boss says. If wallet cash, which is 25, so think about this as 25 here, is greater than movie price, which is 20. So 25 is greater than 20. Console log, watch a movie. Else, go home, bud. So we should see watch a movie. So I'm going to hit save and run. Sweet. Now let's say that we change this operator to be the opposite. If wallet cash is less than 25 and movie price is higher, let's see the difference. Save and run. Go home, bud, because we don't have enough movie monies. So great example of thinking outside the box and trying to figure out an example that could be used here. All right, let's go over here. Margarita, let whole world if word. Hello, good. Yep, perfect. Jessica, let age 30 if age is less than 21, return over drinking age. Else if age 21, return check ID. Else return not drink. Okay, let's look at this one. This is an interesting one. So we've set up our age here. And notice no semicolons. Now, look, I like that you're getting in this habit, but I think it's maybe too cool for school. So we got to be careful with these lacks of semicolons because there are some linters out there that can yell at you, but I appreciate it. So if age is 30, so age is 30 is greater than 21. Oh, we have a return statement over here. Interesting. So this is something we've not talked about yet. So return over drinking age, else if age is equivalent to 21 with just double equals, so I wouldn't know if it was a different type. So that's something to be careful about. Return check ID, else return not drinking age. So here's the thing. If we try to run this code in the console, uncaught syntax error, illegal return statement. So this return statement needs to be inside of a function. So this thing is going to be freaking out because it's trying, you can only return, or you should be getting an error saying, hey, this needs to be inside of a function. So instead, what we can do is console.log this value if it's not inside of a function. So I love that you're trying these things out. The reality is we've got to use console log if we're not using a function inside of here. Pretty interesting. Okay. I love this stuff. This is super great. Courtney, Let letter 5, if letter is 2, console log, this is false. Yep, perfect. Oh, so this is interesting. So Courtney's not using an if else. Courtney's just using 2 ifs. So in this case, let's bring this in. That bullet for some reason. So in this case, because there are 2 ifs, they will both run separately as if their own statements. So if I hit save and run, you can see it says this is true. But if this was also true, it would run as well. So if I hit save, clear, and run, you'll see it runs twice, even though I changed the language. So that would also be true. So that's the danger of having multiple if statements if you're trying to accomplish one thing, or if you're trying to accomplish 2 separate things, 2 separate if statements is great. So this is a good example of making sure you know what you want. Do you want multiple if statements? Do you want multiple decisions? Cool. Use 2 if statements. Do you want one decision? Use 1 if statement. And then you can use else. Pretty cool. Okay, I keep messing up your name. D'Artagnan. D'Artagnan. Oh, such a cool name, and I'm probably just butchering it. So I'm going to come over here. Coolian. So in this case, we need to make sure that we're setting up the variable, right? So we got to say like let Coolian. Otherwise, this will throw an error. So let Coolian assign the value of true. If Coolian false, or is equal to false, I should say, Coolian is false. Else Coolian is true. So we hit save and run. There we go. Okay, good job, everybody. I'm not going to go through every one, but I'm super, super happy to see. Nina, give me your code. You said you got a return error too. I want to see your code. Just paste it in here. I want to walk through it and we can figure out what's going on. Marcus says, let my age assign value 33 or 33. Interesting. So Marcus, did this work out for you? Putting an a variable is supposed to hold just one value versus that. So that's an interesting concept there, Marcus, to throw these ages in. Felix said he messed up big time. Great. Let's look at that together. And then after this, we'll take a break and then we'll go into for loops. Okay. So this is Felix's code that I just clicked on. Let's see. Run. This looks right. So maybe this is my code that you ran. So Felix, if you want your code, and this is everybody, by the way, you should have the button up here that says fork. Because this is my code, you're not going to see it. But if this was your code, meaning you took this code pen, there's going to be another button over here that says fork in this menu. And if you hit that button, it'll actually fork the code away and make it your code. But if you don't do that, then you're only going to get my code. So that's something I thought we talked about, but I'm realizing now maybe we haven't. So inside of CodePen, if you ever want to take my code and make your own code from it, hit that fork. Okay, so Felix popped this in. So Felix says, I screwed up big time. I got to tell you, Felix, you're not screwing up big time. This is just something for us to learn from. So let some hunger, this all looks good, assign the value of more food, looks good to me. Let some food assign the value of salad. So this is all really good, well-formed content here, or JavaScript. Let's go look at our if statement. So if open and closing statement. So here we go. Felix, I'm so glad you did this. This semicolon is not something we want because it does terminate the statement. So we don't want that semicolon right there because it's going to jack up. It's not even going to let you get into your curly brace. So be very careful with how you use semicolons because that's what happened in this case. So this semicolon got jacked up. So now once we're in the block of code, we can look at our console log and you can see here, the console log is getting jacked up. because we're using a single quote on the outside and we're also using a single quote on the inside. So remember, we talked about if we're ever going to use a single quote, we've got to use double quotes on the outside. Otherwise, it's going to throw an error because it thinks it's a bunch of different pieces. So that's another issue, which I think is so good that thank you for sharing this, Felix. I know it's not fun to be like, my code sucks, here it is. This is so helpful for everybody to see. So we're going to come over here and we're going to keep forming up our code so it's easier to read. So we're going to do that. And then we have this else statement open. So this is perfect right here. This code is looking great. And then we'll put this down, but you'll notice something. Your single quote again is shooting us in the foot. So we've got to use a double quote on the outside if we're going to use an apostrophe. Otherwise we get that weird broken error, right? And then we'll put a semicolon at the end of our statement there, even though we don't need it per se. So, okay, now we've got this set up to be more accurate. Let's look at our logic here. So some hunger, which is more food in a string, needs to be directly equal to more food. Now, this is not going to work because it thinks it's two different variables. So remember, when you're trying to compare a string, you've got to put in the strings. Otherwise, it thinks it's a variable. Then we're going to use the double ampersand, which is great because we're saying and. Then you're comparing the variable some food. And again, here's a salad, but remember, this thinks without quotes, it's looking for a variable. So we've got to put quotes around it to say it's a string. Okay, now let's see if this code runs. So I'm going to hit save and run. You're hungry still. Good job. So if some hunger is more food and some food salad, you're hungry still. So we got into that. Now, if we change the statement to say something new, so it wouldn't be equivalent to salad. Let's see if we can get the other one to pop. Save and run. It should say you're fine now. You're fine now. So there you go, Felix. Hopefully that was helpful. I'll post the code back inside of here. But I love that you posted that, Felix, because it just shows that like just some strings really were off. That was the only thing messing you up. Everything else was good. Post the code in here and then get rid of this. There we go. So if you want it back, Felix, there it is. Okay. For some reason, it didn't throw me an error when using the let when defining the variable. User error, as I've been learning Python before this class, I'm trying to adjust the syntax. Lol. How come it didn't throw an error though? Is that a CodePen discrepancy? So you'd have to show me your CodePen so I can understand, but I bet there's an error actually. Nina, you're saying you seriously needed that. So Nina, where's your code? I want to see it still. It'd be awesome to walk through that too. Let's see. Unless the code's gone. If not, no worries. But I want to make sure that we jump into some of those things. Even if it, like Felix, he took a lot of guts copying his code out there. He'll get it to me. Okay. No pressure. Seriously, no pressure. Okay, let's take a 5-minute break. And then when we come back, we're going to jump into for loops. And well, actually, let's see if there's any questions in here. No questions. Okay. If you have any other specific questions, or if you want me to review a chunk of your code, let's do it. But let's take a 5-minute break right now so we can just get our brains reset. So 5 minutes, ready, break. All right. Break time is over. D'Artagnan, coolest freaking name. Look at your code here. So, all right. So D'Artagnan was saying, hey, I wasn't getting an error. Okay, I can see why you were not getting an error. So the interesting thing in JavaScript is if you do not declare a variable declaration, so if you don't say var, let, or const, so like you're doing here, but you are using the assignment operator, what happens inside of the browser is it automatically makes that a global variable, which is actually super dangerous in terms of like long-term upkeep in your code. So that's why there's no error, because you are using the assignment operator. Therefore, JavaScript says, oh, that's a global variable. So the way we can control that, of course, is to say let, which would not make it global. Now, the irony of this example is that it's on the global scope. There's no other thing here. So no harm, no foul, but I do want you to know about that so you understand like why that worked. So thank you for posting that. It makes a lot of sense. Okay, anybody else? Nina, specifically, have you found your code yet? I want to see if your code's here. If not, we'll just jump on. I want to walk through anything that you would like me to walk through. Let's see. Let's see here. Let's see. Where is Nina? Maybe she had to jump out. Okay. All right. We'll move forward. So the next thing, the last thing I should say, is going into our code and looking at the for loop. So we learned that like by putting a letter in here, right, that we're checking a Boolean. But there's something else going on here. We're getting a lot of items coming through here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 articles. That's a lot of articles have this letter in it, the letter I. So how did we get all those articles to show up? Well, if we go over here, we can see that we're saying for every article, go through each one, and for every article, do the following. So this for loop is how we can, in programming, do what humans can't do. So as a human, I cannot loop through 1,000 things in milliseconds. So for loops is like really when we start getting into things that humans can't do really well. We can reason. We can say if something's truthy or falsy in our own worlds, right? Don't touch the hot thing, it's hot, right? that's a Boolean. But for us, if somebody were to say, like Carlos, if I were to say to you, give me 10,000 variations of lowercase articles on the New York Times, you'd be like, screw you, man. Like you wouldn't want to do that. And it's because you're not a computer. And so, but we can go to the computers and we can say, hey, computer, for as many articles as there are in this world. So we'll talk about this later this week or on Monday, Tuesday. Keep thinking the week's over, geez. But for a number of articles, so I could say 10 here, by the way, give me back the results and do something with them. That's amazing. That's so powerful for computers that they can do that and humans can't. So for loops allow us as humans to interact with computers to do things that we physically cannot do at the same speed. So this for loops are kind of interesting because they start to get into a new territory where we as humans do not thrive. So for loops, these are used for going over items and returning each item for us to do something with. Now, what the heck is a for loop syntactically? Well, they're scary as heck. So for loops, when I was a new developer, for loops, I think I didn't understand for loops for a couple of years. I'm not even exaggerating. For loops, you're going to see in a second, they just look freaky. They just don't look like if statements make a lot of sense in terms of you put something in the if statement and something, something goes out. For loops just look gross. So for example, that's pretty freaking clean, right? If do something, do something. For loops are super just nasty looking. So here's how they look. For open and closed, same thing as a if statement in terms of like if you look at just their basic structure, that they're very similar, but they're not doing the same thing. They're not checking for truthiness. So let's go look at for loops. So for loops are looking for us to set up a value. So they need a value, and then we use a semicolon inside of here. And this is weird because we're used to semicolons stopping statements, right? Well, that's because we actually are going to have 3 unique statements inside of here, and the third one doesn't need a semicolon. So it's, again, a confusing thing when you first see a for loop. Then we need to know what we're comparing against. And then we need to know what should I do next? And for how long? So a for loop is just like, what the freak? And actually, this should be the starting value, starting place. So when you're thinking about looping over something, if you're thinking about going on a journey and looping through, and it's like, where do you start? Well, you start at 0 usually. Usually you start at 0 and then you work your way up. So in the example where I was like, Carlos, 10,000 articles, go. Well, Carlos would start at the first article and start going, right? Same thing with computers. We usually start with 0. So what we can do is we can say let, and then we can use an iterator or a starting place, or we could say like starting place. And then we can assign the value of 0. So we want to start at 0. Now here's the interesting thing is because for loops are used so much, developers have stopped trying to be descriptive with this, and they call it an iterator. And then they're like, well, let's stop calling it iterator. Let's just call it I. And so that's what's happened with for loops. For loops start with an I, it stands for iterator. And that's why you'll see this all the time. But again, you could call this whatever you want. It's just a variable, starting place. Like that is valid code. But I want you to know that almost every developer I've ever worked with runs a for loop like this. They say, let I assign the value of 0 because they always know this is going to be the start of their search, the start of their looping. Okay. So that's part 1. For loops have 3 parts. Parts of a for loop. Number 1. Oops, this is not a big one here. Big comment. Number 1, you need a starting place to loop. An iterator. Okay. So in this case, we iterate and we start at 0. We're going to start our counting. Now we need to compare against something, and it's like, how long are we going to loop? So in the example that I gave Carlos, I said 10,000. 1, 2, 3, that's 10,000. So what we can do is we can say, how do we loop to get to 10,000? Well, we can say, as long as it's not 10,000, keep trying to get to 10,000. So there's a Boolean there. We can a truthy and a falsy. So we can use our comparison operator and we can say, all right, if 0, as long as 0 is going to be less than 10,000, let's figure this out. But here's the thing. We don't want it to be 0, the number. We want it to be the iterator, like our starting point. So we're going to say, as long as the iteration, like our current iteration of where we are, is less than 10,000, keep running, keep searching, keep doing work. So this is the equivalent of if I said, Carlos, you got 0 done, cool. Now get 1 done. Now get 2 done. Now get 3 done. Now get 4 done. Like that's what this is doing. But instead of writing each number that's silly, we can use an iterator that we just set up over here to be our placeholder. And then we can use what should we do next? So Carlos, what should we do next? Keep counting, right? Like keep going until we've hit 10,000. So the way we can do that in JavaScript is we can use this new thing called plus plus. This is a new operator you've not seen. So what plus plus does, so sorry, let me go back here. Number 2, how long do we run the loop? Usually compared to a number or variable. So it's always going to be like a number or some kind of variable that has a numerical value. So in this case, the iterator is our starting point. It's at 0. So it's as if this is 0 right now, right? But it's not. It's just I. It's holding it. So it's pointing back to 0. And then as long as this statement is not true, go to this third statement. And so in this case, we're then going to say I plus plus. And it's like, keep doing the thing we want our loop to accomplish. Usually going to be incrementer. So this is called an incrementer. So this plus plus is an incrementer. By the way, there is a such thing as a decrementer. So there is a thing minus minus. So we'll talk about that a little bit, but plus plus is where we're going to stop. So now this for loop is literally doing is starting from 0 and counting to 10,000. I'm not even kidding. So let's prove it. Console.log. This is running. So let's see how many logs we get when I run this. Should be 10,000. Save and run. There's 10,000. Isn't that crazy? I mean, that is crazy. That's humans can't do that, at least effectively. So this is the power of programming. The fact that you can do something as silly in this contrived example of running something 10,000 times. But where 10,000 actually would matter is think about Facebook. Think about Twitter. Think about how many tweets are actively coming into the Twitterverse every second. I don't know the answer, but I bet it's in the millions. And so I guarantee you there's a loop that's trying to figure out how many tweets are going through and then displaying them for your user account. So these loops are extremely important to us as human beings to be able to do really repetitive things over and over, like this article that we started off with. So let's go look at the code. So right here, we're saying, okay, every time someone hits a key, so key up, meaning when the key goes up, run this code. When this code is run, we say, okay, every time somebody hit a key for let I equal 0. So, right, Carlos started 0. Then we come over here and we say, how many articles are there even available? And we're going to learn about this on Monday and Tuesday, where we can actually create an array of information and then find out how big the array is. So that's how we're getting our 10,000. We're finding out how many articles actually exist inside of our code. By the way, we can go look at our articles right here to see how many. So here's our articles just to get rid of some of the magic. It's just right here. We're going to talk about this on Tuesday. But basically of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Like 13, I probably missed maybe. Oh, they're even named. What do you know? So 14 articles that we're going to be looping through. So the cool thing is instead of having to type in 14, which is bad because that's a hard-coded number. It's not dynamic. So that means that what if we added more articles tomorrow? Well, then we'd have to like go do the math and manually update that, right? So we're going to learn about data structures and understand like why we don't want to have hard-coded numbers on the right side of that. But for now, I think it's interesting to show you that this is really just a number at the end of the day. It's just 13 articles or whatever. Then we're using an incrementer to then go over the next article as soon as we found the first one. But what's really fascinating is we're then going through each article and doing something. So first, we're going through the article and setting all the titles to be lowercase for our search. Why? Because we don't want to mess with uppercase or lowercase when we're trying to compare things. Because case does matter. Uppercase A can be a different word than lowercase a to a computer program. So that's why we try to level set all of the data to be the same first. Then we use an if statement. Hey, we know what if statements are. And we're checking to see if this is truthy or falsy. So the title dot includes. So let's see up here. See how this says title? Dot includes, and then dot includes goes and grabs this string. Now notice what we did. See how some of these have capital C, capital O, capital N. So our little thing right here, this line of code level set everything to so we don't have to worry about case sensitivity. We just compare the lower strings to each other. And then we're going to say, does the title include search text? And the search text is equivalent to the value of whatever we've clicked on with the key, whether that's D, F, G, H. So we come over here, D, F. So right now there are no articles that have a DF back to back like that. But if we have an article that says like NEW, you can see that there are articles that say NEW in them. So every time we hit a new key up, the search text updates in a millisecond. That's the power of computers. So we're going to say for let I assign the value of 0. So this is our starting point, right? 0. Go through the first article. We have a total amount of articles, which is 13 or whatever. We then iterate, so meaning go to the next article after you're done. So that's how we know that we're looping. This is our big loop. But the stuff that we do inside of it's where it gets really fascinating. Because then we're saying, first off, set up a new variable and pass in the articles that are coming through. Then make the titles smaller so we don't have to worry about case sensitivity. Then we're going to say, is the title that we just found match the letter that we put into the input box? If it does, then add results to the page. And then that's how we have, every one of these articles has an S in it, for example. And then if we say SE, only one of these articles has SE in it. All right, so that's how for loops can work in the wild. And that's very, very realistic, by the way. This is not realistic. This is contrived to show you like computers can do crazy things like 10,000 things really quick. So let's go over here. I'm going to say 10. And then let's just see that this is not 10,000. It's much more consumable. This is running, this is running, this is running 10 times. So right now, this isn't very helpful for us, though, compared to like the for loop we saw over here, right? So what we can actually do is we can actually use this variable. It's available to us. So this is really cool. We can actually find out where are we. So we can say, where are we in the loop? And then we can come over here and use concatenation, the plus sign, to add something and find out where are we. So we can do a space here, and then we can find out the I position, right? Because it's just the iterator. It's where we are currently. So let's see the difference between, I'll keep this here, I won't clear the console. So this is before we put in the I. This is after we put in the I, so we can see how it actually runs. So hit run. And you can see, where are we in the loop? 0, right? Because we started at 0. Then it runs again. Where are we in the loop? 1. Because why? Because we added to itself this I++. Run it again. Where are we in the loop? 2. Why? Because I++ added 1 plus 2. Or sorry, 0 plus 1. Then 1 plus 2. And then just 1, 1, 1, 1, 1, 1, 1 down the row. So this is how computers loop. This is how computers go forever. And so you can actually create an infinite loop very easily on accident And you can actually, like, if I ran an infinite loop right now, there's potential the Zoom could break. My computer could overload. I'm serious. So we have to be careful about running infinite loops because computers are not humans. And so when they get instructions from us that are silly, like go do a bajillion calculations, they will try to do them until the computer cannot handle it anymore. And this is called a stack overflow when this occurs, which is now you can maybe see some of the irony of why Stack Overflow, the website, exists, because it's funny because it's too much information overload. Anyway, so in this case, I is less than 10 is not going to overload. It's fine. So how could we make this statement an infinite loop? So I'm going to jump over to our Slack and say, how could we make this loop go forever? So go ahead and jump in here. So Kai says, remove the I. So if we remove the I, what would happen there? It might actually cause a syntax error. Let's try it out. Clear, save, run. So you can see we're getting a syntax error, so it's not an infinite loop. I is less than 0 or greater than 0. Okay, that's really interesting. So if we said this, right? Because this is 0, right? So it's as if we're saying 0 is greater than 10. Will 0 ever be greater than 10? No, it'll never be greater than 10. Therefore, infinite loop. So just by swapping the comparison, that's how easy it is to break our code. Okay, I'm going to see what we can see if we can get an infinite loop here without breaking everything. Here we go. Okay. All right. Is our code running? Let's see here. Nope, it's not running. It's not going to allow us to do anything. So maybe we have to hard code the 0. Maybe it's just preventing me from running it. Yep. They must have something in here blocking me from doing it. But this normally would break. So we have to be careful about that. Maybe CodePen has an infinite loop blocker in there. Let's see if we can go into our console and see if we can break it. So come in here, inspect, zoom out, console. Okay, now that we're not in CodePen, this should break it. So we run it, and you can see it's freaking out. I actually can't control my browser anymore, so I'm going to turn this off. Oh man, please turn off. There we go. Okay. So my computer fans just went on. I just went whoosh. So you can see with one little symbol, we can goof something up big time. So programming is super powerful, but as we know, with great power comes great responsibility, right? So we have to be careful about using these loops. Now, it's not something you should be super nervous about. Oh my gosh, you'll know really quick if you've got a forever loop. Your computer will shut down. So just make sure that you understand, like, it's there so you don't do it. You've got to know things that are there that you shouldn't do, like an infinite loop. Okay, so this is all you will need. Now, here's the interesting thing. There's an operator that we can use that can actually add numbers together. So let's say that I have a total sum or something that I wanted to add. So I could say, let total sum sign the value of, and we'll say 0. So it starts at 0. And let's say that every time this thing ran, let's just say we wanted to add 1 to it. So the way this could work is really interesting inside of a for loop. So here, obviously, this was interesting to see, but I'm just going to go and put a number in here now. So total sum. So before I do anything, I'm just going to hit save and run. Let's just see what happens. It should just say 0 10 times. There it is. Because we didn't add anything. Nothing happened here. So if we wanted to add a number every time this ran, we could do something like this. We could say total sum is assigned the value of total sum plus 1, right? Because we could just say 0 plus 1. Let's see what happens here. So I'm going to hit save and run. And you can see that gives us 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. So this got us to where we wanted to get. But the interesting thing is we can actually make this a little bit easier to read. So I'm going to keep this line here. But there's a really cool thing in JavaScript called plus equals. So what we can do is we can say, go over here, and we can come in here and we can say, hey, the total sum is going to be plus equals, and it's going to take all this stuff that we wrote up here and should give us the same result. So we're going to hit clear, save, and run. And we get the same response. So what's happening here is it's instead of us having to write this whole thing out, total sum equals to total sum plus 1, JavaScript gives us this really cool operator that is allowing us to increment and update a new value. And you're going to see this a lot in JavaScript. It's the same thing as this line of code, but as you can see, it's very much shorter and easier to read. So you're going to see developers use this quite a bit. And by the way, you can also do minus equals. And basically any of the arithmetic operators will allow us, so we can go negative. So this is pretty cool. I wanted to point that out to you because you will be using that on your module project this afternoon. Hint, hint. So I'm going to say run, and you can see here that we can add this. Okay. So that is the extent of our time. I'm going to stop here, answer any questions. Then, of course, we'll get off to our break. Okay, is it possible to run multiple math object properties in a single line of code for a single variable, for example, random and floor? Yes, Bradley, totally, you can do that. So what you can do is you can just chain them together. So you can say math dot, like in your example, math dot random, and then you can do math dot floor right after that. So that's really cool, Bradley. Good thought there. Justin says, why did you just put a space between the question mark and the quote? Console log. So the reason I did that, Justin, and good eye, by the way, the reason I did that is because if I put this concatenator in, so if I put like, whoa, I'm in the wrong code pen, the old code pen, here we go. Okay, so the reason I did that is because when I use a string, so I'll bring that back, I'll say console.log, the string, this is the current iterator. And if I do a plus, and then I put the I in here, what it's trying to do is concatenate it right there. So if I don't put a space in, it's going to be jammed right next to it. So watch this. Save and run. And then you can see how it's jammed right there. So that's why I put a space. So if I save it, clear it, and run it, you can see it respects the space and gives me the little spacing that I want right there. So it's really just an aesthetic thing. But that's pretty cool. Good eye. Okay, Isaac says, when would you use plus plus I rather than I plus plus in for loops? So plus plus I adds the number first and then goes through. I plus plus takes the number and then adds it. So I've never really had to use plus plus I, and almost every for loop ever I've ever written is I plus plus. So don't overthink that one. That's a good call out, but I don't want anybody's brains exploding more than we need them to. Like, this is just fine for what we're doing right now. So what if you wanted to count down, right? What if you wanted to what if you had 99 bottles of root beer on the wall? Well, you could come down here and you could say minus minus, and then it would count down from your total number. So there's some pretty cool things you can do. And I'm going to stop there because, again, we don't need our brains to explode. But the concept is the same, is that this is our starting place. This is our total number that we've got to go through, and this is what we want to do next. So that's just some really cool things. For loops are going to be part of your life for the rest of your life as a programmer. They will never go away, and you need to embrace them and learn them. So memorize this, and just get used to practicing. I would recommend you go write this like 100 times. I mean, we're talking, the old wax on, wax off, for loop, for loop, for loop. Just go write a bunch of these this afternoon. Just get in the habit. Just go in here, just start writing them slowly like this, just like let I go 0. Okay, cool. Put some space in there. Like just writing it's going to give you the practice. I wish someone had told me this, just to go write a bunch of for loops, Josh. I would have been that much better just by writing the stupid things. So keep that in mind, that I would recommend that you go just challenge yourself right now to write 100 for loops this afternoon, just for the practice, and make sure each one can run. That'd be amazing practice. Just get some fingers on keyboard and get used to the for loop. Okay. There you go, my friends. This is heavy. I told you it took me, I'm not even kidding. I'm not trying to say this for hyperbole. It took me like 2 weeks to understand a for loop, and it took me years to really like grasp it. So just keep that in mind. I know this is hard. So slowly but surely expose yourself to it. How do I know when I have to write a semicolon? So anytime you finish a statement of code, Felix, is a good time to write a semicolon. So for example, at the end of this right here, good time to write a semicolon. At the end of here, not a good time to write a semicolon. Why? Because this curly brace is part of the statement. Semicolon right there? Nope. We don't want a semicolon right there, because the end of the statement is actually here. Could you put a semicolon there? Yes, you could if you wanted to. So always, Felix and everybody, always try to go to the end of a statement before you write a semicolon, or you're going to get those errors. So this is the end of one statement. So that's why I have a semicolon. This is the end of one statement. But this for loop, if you think about a for loop without any guts in it, that's what a for loop looks like. So you don't want to put a semicolon here, because that's not the end of the for loop. The end of the for loop's right there. So you could put a semicolon there if you wanted to. So Felix, the end of a statement is the answer to your question. Hopefully that was helpful. Okay. Other questions? All right. What about the ones inside the for loop? Same thing. So same thing inside of here, like I said. So statement, semicolon, statement, semicolon, statement, semicolon. So anytime you're trying to stop doing something, semicolon. Okay. It's just going to be practice too, running the code. And then remember, errors are your best friends. So you open that console, you read the errors. If it says syntax error, that means you got a semicolon in the wrong spot. So just keep that in mind. And the same thing with the quotes, Felix, like you were showing earlier, like that, right? Like you were like that, that's going to break it, because this thinks it's just one string. It says this you, right? And it thinks this is a variable. So we have to use double quotes on the outside if you want to use a single quote on the inside. So just remember that too. Okay, lots to remember. That's why we practice. It's also why we take breaks so our brains can consume all this data. So my friends, I will see you on Monday, if not sooner. If you ask questions, of course, I'll help you. But just keep that in mind, that we won't be having class tomorrow or Sunday. We always have the weekends off by design. I do recommend, even though if we're off, that you do watch the videos over the weekend, just so you can like prep yourself for Monday, because we're going to go even deeper on these concepts. And then Tuesday will be our last day together, and then for JavaScript. And then we'll do Lambda launch on Wednesday and Thursday, which is our school orientation. I'll be your instructor for that as well. And then Friday of next week will be off, and then Thanksgiving. So you've got a lot of time to prep. Like I told you, you've got more time than any cohort I've ever taught in terms of getting ready for the first week. You're the most prepared in terms of exposure to concepts early. So you're in a good spot. You're in a good spot. If you're feeling like your head is mush, this is just overwhelming. It's okay. This is like where you need to be. You're getting exposed. You're seeing these things. Imagine doing this without me. Imagine doing this by yourself and some YouTube videos. You'd be like, holy crap. But instead, we can, I'm here to help you. You can ask me in the afternoon. Of course, you can ask questions live during instruction. Take advantage of having me. Please ask me questions. Okay. Thanks, everybody. I'll post this on YouTube. I'll post the link, and have a good weekend. Otherwise, I'll see you in chat. Bye, everybody.